truss we made. Just before we start, I'm going to show you some helpful little cheat sheet we made with 9 helpful equations. The first one is going to be a triangle is always equal to 180 degrees. You have Pythagorean theorem, sin, cosine, and tangent, opposite over hypotenuse, and so on and so forth. The moment equation, the sum of moments is equal to 0. The sum of the f in the x direction is 0, and the sum of the f in the y direction is also 0. And also, during the video, these 9 equations will pop up in the top right corner when they are needed. So this is the truss we made, and as you can see, or you will see, these 2 equations, the angles will be equal to each other, and a helpful hint to know is that this is a right angle right here, and a right angle here. So right now, we know that these 2 triangles are the same, so when you found out the angles, you realize that these 2 are going to be the same. So these is going to be 53.1, on the other side is going to be 53.1 also. But this one is different because of the length right here is different also. And so this right here is going to be 63.4, 53.2, 63.4. And in order to find this one, you need to add these 2 up and subtract by 180. And now we will be going over to Marcelo to find the reaction forces on the truss.
So once you added all 3 loads into the moment formula, they should all be summed up to negative 850. Now we're going to move on to the pin's reactionary forces. At pin A, the reactionary force that goes across the y-axis is 0 because it starts at 0. And then we move on to roller C. The reactionary force at pin C is 10 because it goes from resistance to 10 meters. So then you go down here, you put negative 850 plus 10 for the reactionary force of C, and then 0 as an equation. Now you have to put 850 over at 0, and then divide 10 from RFCY to divide 850 by 10, and then you would get 85 for roller C. Once you get roller C, subtract that from 150, and you would get 65. It's that simple.
With joint A. Now, if we take a look at joint A, we have 2 forces vertically and 2 forces horizontally. Just take a look at what our reaction force is here, and if it's going up 65, we need to repel that with 65. Now, let's look at our 2 horizontal forces. So we simply use our trigonometry, and you should get 48.8. And so if you get 48.8 this way, we need to repel that with 48.8 this way. And once you have these 2 measures here, you find the hypotenuse, and it should end up being 81.3. Now, if you take a look, joint C is almost the exact same thing, just a different reactionary force. So keep that in mind. Take a look at joint D. We need to do the same exact thing, except there's just another arm here and more vertical and horizontal forces that we need to take into consideration. First, we have 25 going down and 65 going up. This will be the same as joint A, these 2 measurements. That means we need to counteract 65 up, so that's going to be a negative 40 plus a negative 25 equals a repelling a 65. Therefore, the 20 goes to the right, so now we do our X. And so if we have 48.8 to the right and 20 to the right, that means we have to have 68.8 to repel it. Now do the exact same thing for joint E. All that you have to do is calculate for this last one. Okay, so you take the imaginary length and width here, and the imaginary length and width here. You put that one here, and so you have vertical, horizontal. Taking consideration of this load here, taking consideration of this force, and they all should equal out to 0.
Okay, viewers, we helped you learn a lot about truss from watching this video, and may the force be with you.